right, how you guys doing? All right, New York City, welcome. Welcome to Clean Energy Connections. It's great to have you guys here. Great to see Green City Force. We are thrilled to bring you our second installment in 2014 of Clean Energy Connections. Just by show of hands, so we know who the audience is out there, how many of you guys have been to a Clean Energy Connections event before? How many first-timers? All right, welcome. And how many self-professed energy geeks do we have in the house? Yeah, you guys are in for a treat. Excellent. So welcome to the people who are watching online. Welcome to our friends at the MIT Energy Club and within the Cambridge community. We're thrilled to have them here. This is a really exciting time for us, and we are absolutely excited about hosting an event on intelligent storage, particularly now, because if you've been watching what's been happening here in New York, the Public Service Commission just came out with what they call REV, which is a proposal to really reform the energy vision in the state of New York. And that really calls for the overhaul of the regulation of the state's distribution utilities that will help the PSC to achieve 5 policy objectives. So number 1, it'll help to increase customer knowledge and provide tools that support effective management of their total energy bill. Number 2, it'll help animate markets and leverage ratepayer contributions. Number 3, it'll help with system-wide efficiency. As many of you probably know, we have the oldest power grid in the country, right here in New York. And number 4, it'll fuel resource diversity. And for the 5th and probably most important thing, it's going to help with system reliability and resiliency, which is incredibly important in this time of extreme weather. But moreover, it's actually going to create an architecture that will help to support distributed controls. And hopefully we'll hear more about that during the panel, and also FERC orders 792, 755, and 784, which mandates battery usage to help maintain grid stability. So again, we'll get deep down into some of the FERC rulings a little bit later. We're thrilled also that our event partner, New York Best, is here. For those of you who don't know, New York Best was created in 2010 as a consortium to position New York State as a global leader in energy storage. And Dr. Bill Acker is going to talk to you a little bit about the work that they're leading. Also, Con Ed and NYSERDA are really active in energy storage in New York. And there's a lot of money to be made within storage. There are incentives for storage, which are up to $2,100 a kilowatt. And for thermal storage, $2,600 a kilowatt. That's a lot of money, and that's part of the Indian Point Retirement Contingency Plan. So we'll hear a little bit about that and the economic opportunity that's driving some of the company creation around here. Lastly, I just wanted to talk about some of the activity that we're involved with at the Urban Future Lab and at NYC Acre, where we're helping clean energy startup companies grow. We have a really exciting company who's part of our portfolio called Voltaic. They're offering some powerful data visualization and analytics tools for batteries, capacitors, and fuel cells, and they're really streamlining data management tasks and putting valuable insights front and center for people who are developing storage technologies. Green Charge Networks is here. Green Charge Networks is another New York City company based in Brooklyn. They're pushing the power efficiency movement, which focuses on the demand or the kilowatt side of the utility bill, offering demand charges and demand response as opposed to energy efficiency. And I think, again, we'll dive in a little bit into the difference between efficiency and demand response. And then 10.6 is also here, offering backup batteries as a service. Lastly, if you don't know, I do want everyone to give a warm welcome to Acquion. Hopefully they'll talk a little bit about it, but they closed the $55 million round of financing just this week. That is good for the clean energy community as a whole, and hopefully we hear a little bit about their voyage and their journey in raising capital, because getting to a round D of financing from backers including Kleiner Perkins and Bill Gates and others, and raising over $100 million to commercialize new technology is quite a feat. And it's good for everyone. It kind of lifts all boats. Before I introduce the panel, my job is also to thank the sponsors. So I do want to thank the New York City Economic Development Corporation. I want to thank NYSERDA, I want to thank Con Edison. We're thrilled to have them back as a sponsor for this event series. And then all the other sponsors who make this event possible. I also want to plug a couple of things. We're going to take a little bit of a break for the summer. Our next Clean Energy Connections event is during Climate Week. It's on September 24th. It's on the future of building energy management systems. So if you're interested in smart buildings and the real estate market, which, by the way, is the largest commercial real estate market here in the city, stay tuned for our September 24th Climate Week event. Also, take a look at NYC Big Apps. If you guys are interested in pitching at that next Clean Energy Connections event, you have a chance to do so here by winning the Big Apps competition. You can search for the Acre Big Idea, which is energy on demand. We're taking submissions now, and there's a lot of great APIs and data sets that you can use to get your submission in for Big Apps, and some prize money as well, which is always nice. And then New York Energy Week is coming up next month. So 2 events just to plug. On June 18th, we're hosting Demo Day at the New York Academy of Sciences, so it'll give you a chance to meet some of the startups who you've heard about today. And we're going to host an energy storage roundtable on June 19th at the Urban Future Lab in downtown Brooklyn, and you're all invited to that. So if you're interested, see me or Simon or Mike afterwards, and we'll give you more info. Thank you for being here. Stay engaged, tweet your questions. We want this to be as interactive as possible. And please help me welcome Dr. Bill Acker with New York Best.
Thank you, Mike. New York Best is delighted to be a partner in this event, the age of smart, intelligent energy storage. And intelligent energy storage is going to be an incredibly important player on the future electricity grid. It's going to solve, and is starting to solve, many of the problems that are associated with our electricity grid. We have a number of issues with the grid that are solvable and tractable by adding intelligence and adding storage together. You probably have heard of the, out in California, a lot of talk has been given to the California duck curve that shows that the load profile over time and the particular peaks that are being created by the integration of renewables on the grid and the need to be able to time shift energy. Here in New York, we actually have a curve that has a similarly compelling message for the need for energy storage, and that curve is the curve of load duration, a number of hours per year. We're at a particular load point on the grid. And this doesn't look like a duck. To me, it looks a little like a blue heron. It's something with a very, very long neck. But it has a very sharp peak on the one side of it. And that peak is the fact that we have very, very short duration, a few hours a year, that we have very, very high need and load in New York City and in New York State. So in New York City, for instance, we have a peak a little over 13 gigawatts. Last year, we were over 13 gigawatts for 7 hours a year. We were over 12 gigawatts for only 29 hours a year. So think about what that means. For 29 hours a year, we had to have a gigawatt of capacity, we had to have a gigawatt of transmission, a gigawatt of distribution, all for just a little over a day of total time. That's incredibly inefficient. But of course, we were designed the grid for peak capacity. Intelligent energy storage can solve this, and it can solve it in a way that creates other benefits. So when you put intelligent energy storage on the grid to start to address those capacity needs, hey, by the way, you're not just solving that 29 hours, you're solving all kinds of other challenges that are associated with the grid. You can time shift for night to day. You can solve peaks at other times. You can do frequency regulation. You can do ancillary services. You can do all kinds of other benefits with that device, as opposed to just having a device idle for only 29 hours a year. So intelligent energy storage is a very, very important topic. We've got an excellent panel for you today to talk about it. Here in New York, I think a couple of very, very important things are occurring right now. You heard Micah talk about a few of them just now. With regard to capacity needs, Con Ed has a wonderful program that's being launched right now to address capacity needs in New York City area, and that's a joint Con Ed and NYSERDA program that you'll hear a little bit about tonight. The other needs beyond just capacity of making the grid more resilient post-Hurricane Sandy, other things that we need to do to make the grid more resilient and to make the grid more efficient. Micah talked a little bit about the new initiative that New York State is undertaking called REV, which is Reforming Energy Vision. This is an initiative by the Public Service Commission and the Governor's Office that is driving for a much smarter, much more integrated, much more dynamic grid that really uses the edge of the grid as the foundation as opposed to central generation as the foundation. Now, that's a really big change. It's going to take a long time to get this through. They started the proceedings on Monday. There was quite a mob scene at the proceedings in Albany on Monday to do that. But they're starting down the right track. We had a call this morning to start to further that process over the next year. The designs for this are going to be created, and we're going to have a straw man out in the end of the summer and processes to start to have a whole new look at how the grid functions in New York State. And New York State is unique in its ability to do this. Only a few states in the country actually have really control of their own electricity infrastructure. Most states have spread the ISOs for the states serve a number of states. Here we have the ability to make these changes and to really take a major step forward in how the grid is architected. So if you're interested in these topics, I certainly encourage you to get involved with New York Best as we do this. New York Best is a nonprofit industry group. We have about 130 member organizations. They range from little startups to large corporations and universities. We also have student and individual people involved as well. So I encourage you to get involved with our organization. Our organization is involved in creating this policy, in funding R&D, and also we developed a testing laboratory in upstate New York to test energy storage systems. So we have a lot going on in New York State with this regard. I don't know if we have the slide for our conference coming up in next week, next Thursday. For people interested in this topic, I also encourage you to attend a conference over here at in downtown with Pace University that will be going into great detail on the siting of energy storage in New York City and the new Con Ed NYSERDA incentive program. So with that said, I think we've got a really exciting night for you tonight. I want to move forward to introduce our moderator for tonight's efforts. And I don't know if we got them coming in yet, but if we can get the panel in here. So I'd like to introduce Omar Sadeh from Green Tech Media, who's your moderator tonight, and the rest of the panelists. So thank you very much.
Thank you, Bill. New York Best is definitely one of the most exciting initiatives in this field right now. My name is Omar. I'm a senior research analyst at GTM Research, a green tech media company. At Green Tech Media, we cover the solar and grid verticals through news, conferences, and research, which is predominantly my area. Today, I'm extremely excited to be here with these distinguished energy enthusiasts. I wanted again to welcome our live audience over here, a lot of familiar faces, and the broad-streamed audience around New York, the States, the world. So, joining me today are Ryan Wartina, Chief Strategy Officer at Jelly, also one of the founding members of the MIT Energy Club, Andrew Reed, Senior Engineer at our hometown utility, Con Ed, and Ted Wiley, VP Product and Corporate Strategy at Acqueon. So maybe we could start off by you gentlemen introducing yourselves again and talking about your roles in your respective organizations, as well as maybe highlighting an innovation in intelligent storage that really gets you excited today.
Okay, I'll start. Hi, I'm Ted Wiley. I'm coming today from Boston, representing Acqueon Energy. I head our product and corporate strategy group, and an innovation that we are really excited about at Acqueon is the significant gains that we're seeing in platforms that leverage the web to allow storage to be interconnected in microgrids and systems of microgrids that will provide a lot more flexibility about how storage can be used on the grid. That's exciting to us because before, the options were more limited. You had sort of a behind-the-meter application for individual consumers that was pretty limited in the scope, and then you had very, very large storage. With this more web-based microgrid platform, we see a lot more flexibility in the ways that storage can be implemented and be useful to the grid.
Great. So my name is Andrew Reed. I'm a senior engineer at Con Ed Research and Development. Our role is really to keep the lights on in the most innovative way, really. But in all seriousness, our group is very focused on providing timely, innovative solutions for the company that meets our strategic and operational needs. From a technology that really excites me, I think that the increased computational capabilities of embedded devices and their reduced footprint, maintaining the same cost or sometimes lower cost, really enable you to do things like install operating systems and push edge computing closer and closer and closer to the assets that we have, and one of them being energy storage. So I'm really excited about kind of what companies are doing in that space.
Great. Hi, my name's Dr. Ryan Wartina. I'm the Chief Strategy Officer and co-founder of Jelly. We're a San Francisco-based software company focused on networking energy storage. We build a energy operating system so we can reach scale, kind of topics that these two my colleagues here have touched on. Also, innovations I'm really excited about is I spent over a decade developing battery technologies. Also have a computational background, but what Aequion's doing, really kind of pushing that price on energy storage can change the world. And also with what utilities are now kind of stepping forward and not being as afraid about energy storage, but now really kind of stepping out to say, how do we do the handshake and the co-communication between different levels of control structures? I mean, it's very important. So what am I excited about? I'm excited about microgrid networks and the Internet of Energy. And that's what we're building, and that's what we're all going to deploy.
Thanks. Seems like the conversation we just had upstairs for like 30 minutes just talking about all those. So on a high level, energy storage has been viewed as the holy grail for smart grid technologies. If we could start off this conversation by really talking maybe about New York and certain drivers for energy storage. In today's market and in New York, where do you see the drivers for energy storage? And what are they? Are they cost incentives or?
Sure. I'll start, and then I assume you guys can
Yeah.
jump in. From our perspective, we think that cost is an extremely important driver of energy storage. And when we think about cost, we think first and foremost about the acquisition cost, but also the lifetime cost of ownership. So with specific respect to storage, we think about cycle life. We think about the efficiency of the asset, and we think about its tolerance to abuse, and therefore the implied requirements for safety infrastructure to support it. And we put all of that together and the cost to operate the asset into what does it cost to acquire it, and what does it cost to own it over its lifetime, and how much value does it create. I also think it's really important that storage that is going to solve problems on the grid be bankable. It needs to be able to be financed in the way that other assets that support the grid are financed. And as I alluded to in the portion where I talk about cost, I think it's really, really important that storage be safe. It needs to be something that can be deployed in and around us in a way that people are willing to allow it to be there. And that means that it has to be something that is non-toxic, and it has to be something that doesn't have a catastrophic failure mechanism if it is, I think, to be broadly deployed in the way that we're talking about.
That's good. I agree with a lot of that. And just to add, you mentioned some of the incentive sides. We have a lot of, for example, like load growth in portions of our network are really driving us to look at non-traditional utility side solutions like leveraging storage. So we're looking at a variety of different companies, partnering with them on different projects, as well as from the incentive side, the uncertainty about Indian Point is really driving a lot of the kind of unconventional thinking now within the team and within the company. So, we have the demand management incentive program looking at the huge incentives for utilizing thermal storage, battery storage. I could talk about some of the numbers in terms of from an incentive standpoint. For battery storage, it's like $2,100 per kilowatt. Incentives for to cover up to 50% of the total install cost. So, we'll have load growth as well as uncertainty and capacity driving a lot of our unconventional thinking and kind of wanted to leverage storage and partner with, vendors out there.
Yeah, from our perspective, there's one of the first driving places has been in microgrids, a type of island microgrids where a solar plus energy storage solution is actually more solar plus energy storage solution is more cost effective than the diesel. I mean, that's key. And then also kind of a hybridization of that. So like island situations really have been one place. Then it's been the California market, because California has the SGIP incentive going ahead and really kind of focusing there at demand charge management, maybe some demand response, not quite ancillary services yet. And now the New York market, another big driver on that. And we're going to see a lot of interesting business models come out of that. But what is also required from business models, kind of what Ted was talking about, and is like we really need like open book data on battery performance, right? We use our software not just for operations, but also for modeling, right? To go ahead and do accurate and comprehensive, forecasting of value, right? And that's what the finance companies really need to go ahead and, get behind that. So that's what we're starting to see is a lot of finance companies are now kind of getting into that game. You might be able to say, is energy storage at where solar was at in 10 years ago, 15 years ago, 7 years ago? You can go ahead and try to draw those analogies, but the difference is we have a lot of solar developers and a lot of finance companies that have already kind of gone up that curve. So they know what type of characteristics that they're looking for on these assets. So, getting down to a good cost, some good business models, some really good financing structures around that. And then again, I can't, reiterate it enough that there needs to be a behind the meter value and also an over the meter value, because utilities can be stakeholders in behind the meter assets. Anyone can be a stakeholder in a behind the meter asset, right? And that's what we're talking about here is like, just like you have different permissions to different computers in a computer network, a bunch of people can have different levels of permissions. So I think there's that level of transparency too.
Yeah, definitely subjects we're going to touch upon throughout tonight. Andrew, you mentioned New York, Con Ed, and partnering with various other companies. We were talking about Electrovaya upstairs. Do you want to share a little bit about what work you're doing with them and potential for other people like our vendors over here to partner with you guys or to take part in incentive programs that you guys put out there?
Oh yeah, definitely. So Electrovaya, we're working with them on what we call the TEST program. It's transportable energy storage. So this is a storage system that can be moved or deployed to a site, like a hospital, if you will. It has a self-contained all the controls, the batteries, as well as the HVAC, as well as fire extinguisher systems and whatnot, to make it sure that it's safe. It's a 500 kilowatt system, 800 kilowatt hour.
Mm-hmm.
So, we're working with them. We're working with EOS on kind of really on a pilot program that we'll deploy at one of our own sites. And we're really in a variety of other programs, but from a Connect perspective, we're very vendor neutral. We'd love to partner with, others to kind of really ensure that we retire a lot of the risk associated with the stationary energy storage applications compared to whether it be mobile applications that are a lot more mature market and electric vehicles, for example. So this market's a little not as mature, it's not there yet, but partner with companies to kind of retire the risk and have a lot of good lessons learned that we can feed into, whether it's policy, whether it's how do we engineer these solutions to make sure that it's safe for our customers.
Okay, and you were mentioning that reliability and safety is one of the major concerns that a lot of end users have of this. I mean, the worst thing that you could probably think about is a potential explosive device on your property or at the substation level. And the first thing that comes to mind when you think about those things, at least to me, and I'm not sure about others in the audience, but is battery chemistry. But today we're talking about intelligence, that added software and control system that's built upon that could help mitigate those hazards. So my question to our panel is, what does added intelligence offer, and how does it mitigate those risks?
I could start.
Yeah.
And you guys could jump in.
For sure.
So when I think about fundamental battery chemistry, there are a lot of different things that can go wrong with different types of batteries. And in almost every case, the failure mechanisms can be mitigated by proper control. And so having the appropriate types of controls in place can really make something that has a potential failure mechanism much safer. And to the point that the point about having that intelligence be at the edge of the grid, it makes it safer still, so that if there's a battery that has a failure mechanism associated with going into a state of overcharge, the failsafe can be co-located with the battery. And I think that, that being said, our position is that the bias for, people that are deploying energy storage and people that are having energy storage deployed near them is that the chemistry itself should be as intrinsically safe as possible, because things can go wrong.
And I think, and you might jump into this as well, as in terms of creating models, any kind of data-driven control, system around the actual battery itself is going to be advantageous for kind of really truly understanding how your asset operates in the field. It is one thing to test it in a lab, but to deploy it and understand how it works in the field and feed that data back into how, a model of how it actually works. And then, utilizing the assets, you want to move from, reactionary to predictive.
Mm-hmm.
You could see things coming, and that could prevent certain unsafe situations. So if you can, have a truly good understanding of your battery system, then it just makes your controls system a lot easier.
And that is why you want to deploy a distributed intelligence system. And distributed intelligence system means it's all spread around, but it's spread around and there's layers of it, right? So if your cloud controller is only collecting data every 1 minute because you have lots of data and data points that you're pulling from, that might not be fast enough. If you're collecting data, 60 times a second and trying to send all of that on, 50 different data points just for one system up to the cloud, that's also a bandwidth hog. So you want a local distributed intelligence piece. I did a postdoc at the Naval Research Lab, and I was trained by some really great, government people on how to get batteries to live a really long time. And I saw back in 2001, there was like 20-year lithium-ion batteries, right? How? Really good sealing technologies, or really good sealing techniques, and a lot of circuitry right on that system, right? And so it's treating it really nicely. And, I think that's important. Like, it goes right into the controls, goes into distributed intelligence. And then you actually touched on it, this kind of the proactive part. And, we can think about internet security, again, as authentication, but the contemporary type of internet security is event-driven management, right? Anything that comes, everything is constantly being watched. It's just not log on and logged, right? So again, really requires that distributed network piece.
Okay, so in New York over here, there was a recent white paper published called Reforming the Energy Vision, where it calls upon Governor Cuomo to ask the Public State Commission to fundamentally change the utility regulation, essentially transforming utilities into distributed system platform providers. What are the goals here, and what does that mean for New York utilities? Maybe, Andrew, you want to kick that off?
Yeah, I think, we have a team focused just on that. It's called the Utility of the Future Group. And, they're working, hard to kind of identify how and what impact that would have on Con Ed, and what does it mean for our customers. And, they're contributing to that effort, and will be. I think it's just recent that they came up with this. But from, kind of some of our team's perspective and my perspective, Con Ed is currently a platform provider already, being a T&D company. But for our customers and for the energy generators. But it has to evolve and to support, things that they call for in that study. It's like, plug and play, capability of distributed energy resources. You kind of need this kind of distributed controls architecture to support that.
I want an API for that.
Exactly. So we'll probably be working together on that. But as well as, to support, incentives and how to help our customers manage, their demand, and take advantage of, these other, things that are out there, like, putting solar on their roofs or, leveraging storage. But, we need this, transparency of information. We need these more distributed control systems, and to really get there. So I think that's what, it's going to take some time, but, if we were able to work together, then we'll get there, I think.
I mean, it seems to me like it offers a lot of incentives for other vendors to jump in there. I mean,
Yeah.
like yourselves. I mean, are there opportunities that you guys are planning? I mean, do you foresee this to bring a lot of opportunities for you guys? And is there a specific sector where you guys see that such an initiation could affect?
Not necessarily sector, but
Yeah.
it's more a methodology. If you think about energy storage as like a hard drive of energy, usually you'd only use an energy asset to do a single thing. But now you have energy storage, it can do multiple things. You can actively do demand charge management, and you can even put a little ripple on that if you want to go ahead and do a little ancillary service. That's an interesting concept, but this is kind of showing that you could actually do both, right? And the idea there is that there's a kind of a behind the meter service, but now there's also a multiplicity that requires this communications with the grid and the utility, kind of a over the meter service too. So I think so to me, that's the methodology, and it requires a lot of pieces to be in place to move forward on that. And one of those is we've just finished interconnecting a system at the City Hall in Benicia, California. It's like one of the first battery-backed level 3 fast chargers, and it's interconnected to the grid. It has solar on it. It's getting SGIP funding. Super exciting. But there was a lot of metering education that had to go on with, between us and also with the utility, because they hadn't really seen this type of system before. It had to deal with this type of metering. And, so I guess that's another piece. We'll push forward on this, utility of the future concept is, I'm going to ask for a very specific ask, which is I want to see some software-based metering with continuous calibration and validation. If that can be put into all electronics, then that's going to help, scale deployment. Right. So I hope that's on that list.
And I just want to touch on kind of one quick thing you just mentioned is moving from single-use devices to dual-use or multi-use capabilities, right? So, having embedded, electronics on, previously dumb assets can enable you to do a lot of different things on the grid, right? So, that added, electronic capabilities and software, allow you to open up a whole realm of kind of other capabilities that we haven't even thought of. So, it's an opportunity for vendors as well. So.
Well, it seems like there are a lot of bundling potentials, for example, and I'm sure that you guys are quite involved in it. Do you see energy storage moving into buildings, into building energy management systems, and I mean, enhancing them, and in which ways? You could please feel free to share your experiences in any of this, and talk about best learnings or that. Yeah. Do you guys integrate into buildings? Is basically the question. And
Yeah.
And what advantages do you offer those building operators?
It's if you have a lighting system that has some demand response capability, and it can only dim the lights so far, you can go ahead and lean on energy storage, right? If you have like the proper APIs and all the software, communications, going together. Again, energy storage is that hard drive that a lot of different assets can work on. We're working with one intelligent HVAC, system. We're starting to, anyways, and they kind of view the building as a kind of a soft battery, right? A soft thermal battery, and they can do some, kind of controls on demand, but they would love to have a battery to kind of lean on. We've just recently done a diesel generator integration, so a battery hybridization for a generator, and that's great because in a cell phone tower application, that can extend runtime. Our co-founder Chris Wagner, his mom was in New Jersey in that last superstorm, and like day 3, no more cell phone communication, right? You can actually extend that runtime now. So integrating into the building systems, other systems, existing systems, I think that's really important to keep in mind, is that what we're bringing with storage is, again, I'm just going to say it, it's the hard drive of energy, and it needs to interface with all the other systems there. So that's why we've structured it as an operating system.
Yeah, we're seeing a tremendous amount of interest in building integrated energy storage in emerging markets. We have one of the largest first projects that we're looking at, and in the final stages of contracting for, is in the Philippines. It's a large resort, and it's currently powered by a diesel generator. It's on one of the smaller islands, and they're putting in just about 2 megawatts of solar and just over 2 megawatt hours of energy storage, and they're going to run the entire resort completely from solar and batteries. That's super exciting for us. That's our dream application. We love the idea of taking solar and enabling it to be a primary mechanism of generation 24 hours a day. And that actually spurred a question in my mind for Andrew, along the lines of utility of the future. When you're in the Philippines, or somewhere that's distributed and there's not necessarily a great utility to provide electricity, it's really obvious to do something like that. But there are also some instances in the United States where it's obvious to generate solar locally and potentially use storage to manage the intermittency of the solar. And I was wondering if Con Edison, when they're thinking about utility of the future, is ever worried that it doesn't include them.
So I don't know if they worry that it doesn't include them, but for example, we have some customers that are interested in leveraging storage for flattening their peaks or their load profiles throughout the day. They can do optimized techniques in terms of pre-cooling or monitoring when people are in and out of the building, but they want to be able to leverage storage for when people go out to lunch, for example, and there's a dip in the actual demand of the building, and they want to flatten that out to minimize their demand charges. And we don't provide generation. Our customers are purchasing energy from other energy service providers. So it's not like we are making money off of that. And it doesn't involve us. But if they're leveraging solar as a means to on-site generation, then I wouldn't go and say it's a worry, but I'm sure they've thought about it. It's pretty early now, and they're talking about it.
Yeah, the specific thing, and I don't think necessarily in the Northeast this is as much of a concern, because I don't think the weather particularly supports it year-round. But I read sometimes people use the word grid defection, and I wonder how utilities are thinking about that. And from my perspective as a storage provider, I'm sort of agnostic to who we're selling storage to, but I'm really concerned as a user of energy about a business model that's potentially disruptive to our customers. Like, I think of utilities as our customers, and as a vendor of storage, if we are potentially disrupting some utilities by taking their customer base away, then that puts us in a precarious position. And so I'm really curious to sort of hear, if you've heard, maybe not necessarily Northeastern utilities, transmission providers, but sort of your cohort in other locations, if you've heard people, express opinions about it.
So people are expressing, opinions, but I think this is where we have to work closely with the PSC, and we're a regulated utility, and we need to come to common understanding of how this will play out. So I don't think there's I wouldn't say that I know kind of, since it's so early, especially with the Utility of the Future group, how, what our own concerns are yet, but it's a conversation that's going to have with the PSC and under what is the right business model that we can come to a common understanding on, right? So,
Yeah, Stephen Chu came out a couple weeks ago and kind of maybe it was an article and basically was saying, hey, utilities might be time to adopt a business model that includes kind of financing or becoming stakeholders in behind the meter assets. And you could take a look at Florida Light and Power. They have NextEra that goes ahead and does, distributed assets. That's a model, right? And then also, another big factor here, let's take a look at Nest, right? These assets are going distributed, and so utilities also have one of the most valuable assets, underutilized assets that was brought up before, which is the network. Yeah. The way to go ahead and do peer-to-peer energy exchange, ultimately, third-party services. You can make more money by utilizing that underutilized asset.
Yeah. So I think one of the business models that may work out in the near term, but one of the things that our customers are concerned about, we want to encourage, we're providing incentives to put in, customer-sided solutions.
Yeah.
But they work with these, large vendors, and they look at these contracts, and they get concerned with, not a clear understanding of the reliability or operating parameters or lack of standardization around it, and they'd much rather work through, Con Ed because they know us, right? And we work with them every day. And, a lot of vendors out there are going to have to provide comfort around this area in terms of, dealing directly with customers. So one of the near-term models may be utility-owned, but on the customer side. But again, a lot of these conversations have to happen. And there's a lot of benefit to being grid-tied. Mm-hmm. Microgrids just don't operate 100%. Completely islanded from the network. Usually they're tied to the grid, providing a lot of stabilization, and so there's still a lot of benefits to being grid tied and completely separating yourself from the utility.
Mm-hmm. Maybe you were telling me a little bit back there about the EV charging program. Can you talk about that a little bit?
Yeah, we worked on 2 programs. Partnering with folks in the industry, working with like GE, Columbia University, FedEx, how we're working to really understand from a commercial fleet standpoint, the grid integration of electric vehicles. So we've worked with them to, install the infrastructure, understand the costs, and then work on advanced algorithms that can actually do demand charge reduction. When people are kind of charging their electric vehicles, they all come home and all charging at the same time could represent a large peak within the building, right? So how do you manage that demand within the facility? It's also with a part of our partnership program, got a DOE grant looking at putting in within a commercial facility electric vehicle supply equipment or charging stations, if you will, that have more intelligent capability but at half the cost. Mm-hmm. And we're working with our partners on the program to really tie those systems in with our utility systems such that we can send DR signals or curtailment request signals and understand what your curtailment capabilities are, what's the status of that site. So we're partnering with people in the industry to really build out these systems. And to your point on, getting an API, that's through this interoperability framework that we're trying to follow. We want to be able to tie in partners and different vendors into these systems such that the customer can still take advantage of a lot of these incentives and programs that we're providing. So,
I remember reading something about Con Ed doing a study on virtual power plants. And it's predominantly a European thing where you can aggregate a lot of end user entities, whether it be storage, whether it be distributed energy resources. And you see utilities in the States, not many of them have adopted that, although if you look at the microgrid scheme, it somewhat is doing that. But you look at Duke Energy, for example, and they're aggregating lots of different end user owned assets. Is this something that Con Ed would eventually look into or further? Or was it just a study on virtual power plants? And how does that impact intelligent energy storage into it, tying I guess, aggregating and tying in all these separate little assets all over, for example, Manhattan.
Yeah, so in Manhattan, I think, I may not be as familiar with the study as you are, but from a virtual power plant, you want to be able to model, different buildings, energy storage, what assets do you have in a particular network, as well as for customers that are putting in like advanced energy management systems, they're able to internally predict what their, demand will be throughout the day. And that's based on their own internal systems. So if they can share these schedules or forecasts with us that are much more advanced, then you can start creating really advanced models within the network of what the demand will be, what kind of storage do you have within that particular network, what kind of electric vehicles do you have within that network that could possibly contribute. So you can develop this kind of virtual power plant on a network by network level, and really truly understand and be confident that you'll be getting, when you call it a DR signal, that you'll be confidently getting what you're requesting. But I think it's an area that we'll explore and continue to explore. So, not a one-off study.
I would say that type of system absolutely requires a distributed intelligence system.
Most definitely.
Why? Because there needs to be a public and a private side of that data, right? There's the private side that the building's using to do its optimization, but then it has its availability, right? Or it's like its forward intention that it can share with the utility, or any type of that data that just to go ahead and preserve that type of public-private line, because I don't think building owners want the utility going and controlling all those assets, or having full transparency of all what operations are.
That's why we call it the curtailment request, as opposed to us actually going in and actually controlling individual asset in a commercial building. That's not what we send a DR request,
right?
And we continually, for the electric vehicle example, where we're constantly sending curtailment status information. What are within your capability, and ensuring that we're tracking that. And when we do want to make a request, that we're confident that we're calling on an asset that's within the capability to actually curtail the load that we're requesting. Right? So
back in the day when computers were like 8 bits or 8 words, they only understood those 8 words. You can only sent that word and it did that thing, right? But
one-way communications is what we're moving towards. Two-way communications now.
Yeah, small computing platforms, and we all actually have energy storage right next to our bums right now, or I do anyway, so where my battery's at. So I mean, like, it's kind of safe. It kind of should be in that structure, of public-private side and computing platform distributed.
Okay, maybe we could flip the conversation to maybe the financial aspect and the access to capital. So many industry analysts have compared distributed storage, intelligent storage, to the solar industry, and which ultimately led to a really high mobilization of private capital. So through examples like third-party financing of residential storage, residential solar. What are the new financial and ownership structures emerging in the distributed storage world, and what are the potential value streams out there that we could really take advantage of? It's open to anyone.
I'm going to jump on that and say I think there should be like 1 million companies that get started that do microgrid financing packages, right? It's just a general going to finance energy storage, solar, maybe a car charger now, 10 later in the future, LED lighting, all that. Wrap it, do it. Okay, that sounds great. That was the ESCO dream, but ESCOs and solar diverged because of some design requirements. Actually, I don't really know. I can only postulate on why, but they did, right? And what we're trying to do is kind of bring them back together. And that requires a very accurate and comprehensive, computationally intensive sometimes, modeling, deep knowledge of, battery performances, asset performances. You don't necessarily back out a power purchase agreement, right, from a storage system. Maybe it's a power efficiency type of agreement, or maybe it's just a power and energy agreement, right? So kind of almost like a customized rate structure for that facility, for that set of assets. I think that's really what the space is going through right now. And then all of a sudden you have to deal with growth. I mean, so the utility is built to kind of deal with load growth on a massive scale. How do you deal with that on a facility scale? Also, when assets can have, certain type of fade characteristics too, and assets need to be replaced, right? So it's not just like what it costs today, but it's like what it costs today and what's the initial value stream, what are the up and coming value streams. Like, yeah, we can't wait until we can actually use a behind the meter asset that can also provide a market service and a utility service, right? But it's not quite there to be able to do all three of those simultaneously yet. Now that almost say, what do we need to do to get there?
It's a good question. I mean, from a power purchase agreement, I think from Con Ed's perspective, we're a little bit cautious about, customers that are, let's say, utilizing, that are no longer or have the ability to switch from, across, who they request their energy, their delivery from. And if they're saying that, they're moving towards using customer-sided like energy storage and whatnot, now we're stuck with these, possibly stuck with these contracts of, we purchase this, these energy. And for some customers, we do purchase a certain amount of energy for them. So, the different business models and whatnot is, I think, something that, we're cautious about and we want to pay attention to in terms of financing a lot of these efforts. But for infrastructure deferment, energy storage helps us support a lot of that, so we can ensure that we get the truth about the load growth on a network portion. It's really expensive to go in and, install a new substation to meet the load growth. I mean, it's on an area substation that's about 300 MVA, it's about $250 million. We want to make sure that you're making this investment, and the load growth is what it is. And to really learn what that is, energy storage provides us an opportunity to really learn about that load growth and ensure that we're making the investments that that need to be made.
I mean, there are a lot of parallels that I've seen in comparing both of these industries, the storage and the solar industry. And in the solar side, you have solar cities of the world where they offer financial packages or incentives for end users to purchase panels. There are other companies out there that we could read about that, like STEM or Coda, that are offering no money down storage. I'm wondering what your opinions are on that. Maybe hopefully stir up some controversy. Are you guys moving towards that? Do you feel like the industry is moving towards that? What's a utility perspective on that?
We work with we work with Coda quite a bit.
Okay.
And so we deployed the very first Coda system, and we deployed the very first Aqueon system. And everyone's going to have to kind of come up with what their finance models are. And if you take a look at the history of financing, how does it start? It's always equipment financing by the OEMs, right? So if there's a heavily backed OEM that can go ahead and finance that, great. That gets the models starting to churn. Second step is you have some third parties come out who kind of grow up to go ahead and start taking that risk on. Then the next step after that is banks, then markets. To get all the way to like market-based type of financing. That's the ultimate goal, right? I think we're finally seeing bank-level financing for solar. It took us that long to recognize that the sun's going to come up every day. How long is it going to take to realize that we're going to use power every day?
Well, I think that the analog is good in that regard, but also a battery is quite different from a solar panel, insofar as the fundamental technology that allows you to store energy battery to battery can be very different between like even the limited number that are commercially available now, and so it's really important for financiers to be able to get their head around that and to understand what the pros and cons of a particular technology are and to have it validated. And I think that My view on how financing models are going to evolve for storage is that initially you're going to see a lot of equity financed projects and manufacturer-backed projects in the early years while people get comfortable with the various technologies. And then I think also there's a lot of variety out there in the technologies that are available. And as such, I think a lot of the large players that eventually have an eye on financing these types of assets are watching, and they're waiting to see how some of these early demonstrations, deployments, and projects play out to take a view on which chemistries and which companies are going to be producing long-lived, dependable assets. And I see SolarCity, Sharp, all of the solar vendors that are financing solar are looking at storage aggressively. They're developing groups that are looking at storage. They're evaluating technologies, and they have their eye on it. And what they saw for the last 10 years was they saw solar, come in, be very cost prohibitive, and then decline extremely rapidly over the last decade because the underlying commodity was declining very rapidly. I think silicon prices dropped 90% in the last 6 years. Driving a similarly precipitous drop in solar module pricing. And everybody who got in early and made aggressive bids on PPAs has a PPA that's way in the money because of very low solar prices. And the people that were very successful, and also the people that were not successful or have watched that with solar and are seeing forward price curve projections in lithium ion and attractive other technologies coming into the market, and they're thinking, is the same thing going to happen in batteries? And so I think that there's will on the part of financiers to get out ahead of it and be more aggressive than they were in solar, but there's also caution because there are more variables in the storage side than there are in the solar panel side. There's more different types of batteries than there are types of solar panels.
I want to jump in on that. There was some of that same case, different types of solar panels, polycrystalline, amorphous, things like that. And I find it amazing that we can come with a 5 to 8 year ROI on a storage system, and people say that that's too much, when we've been living in a 9 to 12 year world for solar. And what I believe is really kind of like the one of the broken gears that we're trying to fix, and some of the work that we've been doing with you, is accurate, comprehensive battery characteristics melded with exact profile, application profile over time to get very accurate. I don't think I think financiers want more of a guarantee of money return, not amount of money return. It can be done over 5, 10, 15, 20 years if it's very accurate, right? So maybe we're still missing some key fundamental data, but this is an opportunity for all battery manufacturers to be very clear with their characteristics of their batteries, not always be bringing that in-house. I call for a public database of battery characteristics that can be used by finance companies. Just to go ahead and level that playing field and get in front of that. Because until that happens, these things aren't going to get financed because there's going to be a lack of clarity on how these things operate into the future.
And I would add to that, oh, sorry, go ahead, Ed.
No, I'm saying I think that's very important because understanding, we need standards around, how do you operate, how do we respond, in case of, the risk associated with installing these on the customer side, and how comfortable our customers are with, ensuring that whether you have UL certification and other certifications on this equipment, and provide that kind of comfort that you're financing something that will provide a benefit, a consistent return, if you will, over time, that we have a very accurate model that's a clear understanding of the chemistry, how it operates in the field, and that it's safe. So I would agree with you on that point.
Basically, roll that into like a PV sys, but for storage, right? Where now all vendors have to kind of put their power converter efficiency curves and their, charge discharge power profile, capacities, all in somewhere. It almost becomes a requirement every time you come out with a new vintage or model. I mean, I think that's, from the inside of, working on designing these systems and getting them financed and deploying them, that to me is like, one of the biggest moves that the industry can make. Is a kind of I think someone said an open book policy on that.
In addition to vendor transparency, I think that it would be very useful industry-wide to establish a series of metrics to evaluate the different technologies on an apples-to-apples basis. Yep. And I think that really needs to be driven by applications. I think that we need to have a standardized mechanism to evaluate several different technologies against a particular application duty cycle under particular conditions. And that needs to encompass the installed system, not just the storage technology. What is a landed asset that provides this service? What does it cost, and how does it perform? And how can it be compared against other, similar landed assets with different embedded technologies?
We have an energy out for that.
Yeah.
Well, it seems like through conversations right now and previously, and especially when we're talking about batteries and we talk about power, which is in kilowatts, or when we talk about energy in kilowatt hours, and it seems like the battery chemistries really play into deciding whether a battery can perform better on one or the other. And when we talk about services, another thing that comes up is ancillary service, like frequency regulation. Are we moving towards something that wants higher power or higher energy, and is it based regionally? Is there a certain, preference in New York, in the Northeast, in California, in the Midwest?
Well, I think in New York, ancillary service like frequency regulation, if you will, I think from a frequency standpoint, we're pretty solid in New York. Mm-hmm. I think the last number I've seen, the market for frequency regulation is about 200 megawatts, and there's a system in upstate New York based on a flywheel that's 20 megawatts, so it has 10% of the market. So it may be hard to get into that market and add in value, but there's other ancillary services that, possible, customers or people that are interested in leveraging storage for. So
it's interesting because the need for ancillary services or frequency regulation is just like the market, balancing because people are taking loads off and putting them on. But as more renewables or intermittent renewables come on, that amount of frequency regulation is important. And there's a little bit of averaging that happens there. But at the same time, there's local hotspots that, come up. I was recently involved on a phone call where there's a branch on a distribution network that is maxed out on solar, like not allowed anymore solar on there. It's like that doesn't really play into the whole overall macro look of the grid and the ancillary services, but there's a very specific place that needs it. So again, like more distribution network metering, I think will kind of uncover more needs and applications for maybe a local type of ancillary services, but that could also just be a product that is supplied by a local industrial facility that has energy storage to go ahead and stabilize a local transformer, right? That does a couple of different things. That's like kind of like that gets this whole like third-party services happening, grid support services, from the customer side, and I think that's a fundamental move there. So anywhere where there's going to be more renewable energy, we're going to need more ancillary or stabilization services, and we see GE putting energy storage into the wind turbines. Smart, right? Like, why renewable energy ever got deployed without energy storage is beyond me. So,
well, I think that renewable energy got deployed without energy storage because energy storage was really expensive.
Yeah.
And I also think that, and just like most renewable energy was at the beginning of its technology life. And what we're seeing now is we're seeing the cost of energy storage get to a point where it's starting to be cost competitive in several markets. And I think what you see is that the power applications that are in the marketplace are the most valuable. And so those are the ones that are getting deployed first. The remuneration that can be achieved on a frequency regulation project is much, much better than can be achieved on a 12-hour load shift. And so what you see is the stuff that deploys first is the most valuable. And oh, by the way, it also maps pretty well to the most commercially viable technology in the marketplace right now, which is lithium ion. Lithium ion is it's optimized for short duration power applications. It becomes much less cost effective after you expand out of, say, 2 hours of discharge at rated power. And I think that there's an open space in the market right now for technologies that are both cost effective and can provide for an application that's in the 4 to 18 hour range. And what I see is a diminishing value of like very high value in the sort of 15 minutes and then declining as you get past the sort of 4 hours. And I think that we discussed in the back room what a target price would have to be to really move the needle. And I also think, by the way, that the sort of market size increases. So you have this very valuable small market in power that becomes very huge market in energy that's less valuable. And I think that the sort of inflection point of value for energy storage is, people talk about it, but we're thinking sort of $300 a kilowatt hour installed. DC system, AC system, landed cost, that opens up a tremendous global market that really changes the game. And I think that everybody's driving toward that. And that's sort of 4 hours or greater of discharge so that the batteries can provide capacity to the grid and potentially perform other services.
Yeah, I think you said it, right in the nose. What we're talking about in the back is, for us, if it's under $500 per kilowatt hour, then it starts getting on our radar. We start thinking about it. At 300 is really where, for us, it starts competing with, other, assets that we could possibly leverage. Below 300, then you start competing with like peakers and whatnot. So those are kind of target price points that we're kind of looking for. So,
and I would quickly add, by the way, that that's like a generality number. I don't think that you have to be $300 a kilowatt hour to successfully deploy a 4-hour project. I think that there are many places where it's much more valuable than that. So the task to the technology providers, the systems integrators, and the project developers is to go find the most valuable nodes on the grid, deploy there first, and cost down the technologies so that this basket of technologies can become transformative. And the transformative number where the entire market opens up and there is no better alternative than storage to provide these services to the grid, to me seems to be sort of the $300 threshold.
There's an interesting turn on all this, which is we've recently started working with Eagle Pitcher they're doing a mix of lithium ion, lead acid, right size for the right application.
Sure.
And now you need like modular power converters, and there's a whole control system really going on here, but it gives you that capability to go ahead and really dial in for power, energy type of systems. So,
we were running projects that looking at the different, whether it's a power application or energy application, trying to ensure that we had a good understanding of all the different battery chemistries and which one plays well for, our grid. That's why, we're working with partners of a variety of different chemistries to truly understand where it fits for us, where is it most valuable. So,
what about this idea of of aggregating lots of smaller batteries and then cycling them on and off depending on what the need is? Have you guys looked into that, or I mean, on both sides, on the utility and integrating them on the vendor side.
And from a utility side, we want to make sure before we go to a wide-scale application that we have a good understanding of the actual batteries. So, looking at it on a wide scale, I wouldn't say that, it's something that we wouldn't look at, but, we're very much focused on really understanding the battery chemistries, how safe they are for a customer, whether it's on the customer side or our side, and where it fits into the overall systems and where we can leverage them. So I don't know if you guys have any comments on kind of that type of.
I think once you start looking at the ecosystem of players, like if you have a battery manufacturer that has provided some type of warranty on the system, they're going to be wanting to watch those systems at some level. If you have a financier who has financed multiple systems, they might also want to watch that. If you have now like someone who's doing a market participation piece, yeah, you're very likely to go ahead and aggregate up multiple systems. Again, second time I can't believe I did it, Nest, right? They're aggregating that. That will happen with energy storage. EV manufacturers, right? Like EVs are a great place for an expensive source of energy storage, but it's already kind of paid for in its initial application. So PJM has the ability to go ahead and operate fleets. Now, being able to connect in assets that then get put into the market, this is a difficult task. There's lots of regulation around that, right? Because you're basically having to kind of go from behind the meter through a utilities distribution network to the transmission grid effectively. So again, I think there's just us working together here over the next bit of time, we can kind of hammer out all those methodologies and who are the stakeholders, but it'll probably happen.
Mm-hmm. And yeah, I mean, there are tons of subjects we could jump into right now that would lead off from that. But I think since we're live streaming, I think there are a few Twitter questions that we could possibly ask right now, and I think we'll.
Yeah, so we have a lot of attention on Twitter from everybody, so this is great. Thank you. Ricky, who heads up the MIT Clean Energy Prize, asks, what role should universities and student entrepreneurs play in the future of energy storage? Jeffrey Irvin, who I think is in the crowd tonight, asks, for Ted Wiley, more variables for storage than for solar right now. Will that always be the case? Divi asks, question for all the panelists, is it inevitable that utility customers will go off grid eventually with solar and storage? And lastly, Omar, this is also from the MIT Energy Club, where does cybersecurity fit into the conversation?
Going to kick it off, maybe we'll talk about cybersecurity? Or?
Yeah, very important. I alluded to it earlier on, which is like it needs to be an active control management combined with local authentication. Internet technologies did pretty well at getting us comfortable to doing online banking, right? Like that level needs to be applied to energy systems, no doubt, right? Like old SCADA networks, old DMP3 standards, old XML, got lots of holes. Right, so those need to be all addressed. I think a real comprehensive local strategy. That's why we build our architecture in a kind of a resilient architecture to where we can actually shut the whole thing down, disconnect from the internet, and still operate. Because you want to be able to operate a microgrid when the internet goes down. So, but that's also a very secure spot too. So, apply what we learned from online banking, distributed intelligence, event-driven security. Yeah.
Mm-hmm. I think I completely agree with you. I think you want to take a defense in depth approach to how you protect your assets at all layers, right? You want to make sure that you're categorizing the risk appropriately, and you have systems in place to mitigate a lot of those risks. So essentially what you're saying, I would buy into.
Ted, do you want to jump on the question about solar and storage, and maybe the different variables in storage? Excuse me.
Yeah, absolutely. I think that as these technologies become as they're validated in public-facing institutions, places like New York Best, with the KEMA partnership, places like Sandia and the national labs, and as data starts to roll out of the first installations and deployments, people are going to get more comfortable with them. And if technology vendors are forthcoming with their data, as Ryan says, that will be tremendously helpful. And if the space in general creates unified standards early on how we test and evaluate the different technologies, that I also think will really accelerate this reduction to a understandable technology from where it stands today, which is, it's still understandable, but it's complex.
But I want to touch on that complex part, which is like, I really feel that this is why we invented computers. Is to deal with, complex calculations and big data and all that, and be able to kind of like crunch that down. So back to the question about what can the university students do right now, start building those structures to go ahead and, deal with this data, do predictive analytics on real systems, physical systems, chemical systems, not just email systems and database structures, right? There's a whole other world, like the energy space, for more software developers to come in and kind of apply their know-how into the energy space. It's hard for a number of different reasons. I mean, because it's just like, it's immense. It's there, it's ongoing. It's not like when the internet came in, it wasn't that much to displace, or when computers came in, right? But here we have a very existing framework that has to keep operating, and we're going to get a utility of the future. We need some standards, but we also just need a lot of tools, and just there's a lot of stuff out there to build.
And I would take that a step further on the university side too. If you're a student at a university and you're thinking about your career, we need you. You should be thinking about coming to help the United States and the world re-envision the way that we provide electricity, because the way that we do it now is not sustainable in the long term. And it's going to take a lot of creativity, it's going to take a lot of passion, and it's going to take a hell of a lot of work. Train for it. Think about what you like and go after it. At Acqueon, we're hiring. We would love to have you. Come and apply for jobs. If you're an entrepreneur, think about, again, what you're passionate about, and go start a company, or go join a company that's entrepreneurial, that's doing something that you're interested in. I'm in New York, and I think I'll make enemies of half of the island right now, but don't go into investment banking. Don't go into consulting. Do that some other time. I think that, at this point in history, there are some really, really tremendous societal problems that are more important than money, and the time is now to start solving them. So for the folks in the audience that are thinking about it, and for the folks that are watching it on the web, I'll say it again, we need you.
I would only add from a university front that in any field that you decide to go into, you're going to have to learn how to manage data and generate knowledge out of that. And I think, even in the utility industry where we're generating, even with a distributed controls architecture, how do you generate knowledge locally such that you're not shipping off data to these centralized processing, nodes in the cloud, if you will, and have this huge congestion on your network, your communications networks. So being able to manage and handle data and generate knowledge locally and act upon that, I think is going to be very, very, very important. From a utility side, when working with a customer, we want to make sure that we're not being shipped just data, but actionable data, things that are actually important. So you want to be able to generate knowledge locally, and how do you, manage and utilize data for managing your batteries, utilize data for making, controlled decisions on the grid at all levels. It's going to be important, and I think it matters in any field that you're in. How do you handle data and data science skills? So.
I think what we're embarking on here is the next layer of the internet. The first layer of the internet was a communications layer. This next layer is there's the Internet of Things, but it requires a Internet of Energy to operate, right? And how I started was I looked at that thing on the wall. There's one, and we call it an outlet. And I started looking at these lights. I'm like, I do not know where this light comes from. I don't know where the electricity really came from. The bits, we can track that all the way back. If you're a computer science major, you know origin, tracking, all of that, right? But we don't know where this comes from. And so try to combine those two worlds, right? Like learning how the grid works, how voltage is controlled on the grid. These things are, they're extremely novel and very fruitful for a computer scientist to go ahead and start thinking about. And you go ahead and just kind of bring computer science knowledge together with like the mystery of how the grid works. That's where the Internet of Energy is born. Right?
Wow, seems like an extremely optimistic and almost an inspirational way, to almost wrap things up. So at the very beginning, I asked our panelists over here to talk about an innovation that would really excite them. And so as we wrap things up, I wonder if you guys could think of maybe a few words that explains an event. It could be technology, market, or nature-driven, that would really bring forward and disrupt this industry and bring forward intelligent distribution, intelligent storage. So as you guys think of that, I just wanted to say, if you guys did enjoy this conversation, Green Tech Media is having our Grid Edge live conference in June, 24th to 25th in San Diego, where we will have topics like this and we will discuss things exactly like this. They will also be broadcasted via our website, greentechmedia.com. Also wanted to thank our sponsors tonight and invite you guys to stick around after the show's over to grab some Brooklyn Lager, some wine, and talk with our panelists and myself. We'll be around for a little bit. And with that, so the three events that will disrupt the energy storage industry. I think we'll start over here.
I think that the thing that is starting to happen, and you see it in the media, you see it in information that's being released by panels of scientists, is acceptance of what the choices that we've made to date around how we generate and distribute and use electricity mean in the long term. And what will be the most instrumental in enabling all of these types of efforts to succeed is for that acceptance to be at a tipping point, to be above 50% in society, to be at a voting tipping point where we as a nation vote for energy policies of the future instead of energy policies of the past. And I think that will drive the ability to create stable structures for financing. It will drive the ability to strip away legacy incentives for technology and energy pathways that won't work in the long term. And I think that it will enable the specific innovations that I hope that my colleagues will talk about next. But for me, it's the tipping point of social consciousness about the way that we're generating and transmitting and using energy.
Good.
In a few words, Andrew.
I would say that, for a grid platform to be very plug and play, with, distributed energy resources, we need to have, my biggest thing is interoperability and transparency. I think, I could go on my computer, I could buy whatever, printer I want, right? And I could plug it in, it goes and finds the driver, configures itself, and I'm off and running. When can we get to a place where, regardless of vendor, that we can leverage software and standards to really enable, ubiquitous, wide area control of the grid, integration with multiple vendors, and the customer has a choice in kind of how they want to, manage their own resources, and feel like they can plug into the system at any time. So,
yeah, those are both great. That's it. I think like the consciousness piece, 5 years ago, 7 years ago, I remember, hanging out with David Danielson in that hallway at MIT and just kind of wondering, like, what is it going to take to get people to really embrace renewable energy? Because it's not necessarily sexy. That was the point. It was not sexy, so we could maybe have to make it sexy, or just something like that. But it's a people thing, right? And it's not necessarily people becoming all energy operators, but it's people, casting their vote. I think you're right on that. And then the software technology, yeah, that's why we built the company we did. And back to both of you is good job on coming out with that battery chemistry with that price point, and Jay's like insight there to go ahead and build it from the ground up like that. And for you guys to build a company around that, you got some great investors back in that. And for you, working with Con Ed and your background in embedded systems, like that's exactly what is needed. It's not just a technological solution, but it's a political and business solution too, which is that enables handshakes and transparency and the network to actually work. And then all you need is like microgrid financing structures, right? Like solar languished there for a long time until someone came up with like kind of like the aggregated resi financing structure. There's room for that to be invented right now, and then a lot of people will follow it, right?
So acceptability, interoperability. I almost want to say sexiness, but I think I'll go with finance modeling.
And sexiness.
And sexiness, yeah. All right, how about a hand for our panelists over here?